I want to watch this one first because they're always funny.
Infinity is a funny thing. It is a useful concept used throughout mathematics, but try to apply it to the real world, and the real world breaks. Thanks to Fabulous for sponsoring this video. Build better habits and achieve your goals. Infinity allows for some very counterintuitive conclusions. Add up all the natural numbers and you somehow get -1/12. Play around with a sphere made out of
Yeah, if you're confused by that one, so am I. But it's a real result.
12. Play around with a sphere made out of infinitely small points, and you can end up with one extra sphere out of thin air. Link every even number with a natural number.
We still gotta watch that Vsauce video.
And you can claim that there are as many even numbers as there are even and odd numbers. Sure, it's fine and all as long as this happens in the hypothetical realm created by the mathematicians. Or was it discovered? Hold on. Was math created or discovered? I'd say the mathematical language was created in order to discover the mathematical truths.
Yes, so this is a big thing because whether it was discovered or created would mean very different things for our universe and implications of philosophy and like what the hell's going on, you know? So maybe we can talk about this in a minute. Let's keep watching.
Pardon the sidetracking. So, as long as infinity exists as a purely mathematical concept, no kittens are harmed in the real world. Or are there instances when this Lovecraftian idea, that is literally too incomprehensible to humans, seeps through the fabric of reality into our universe? Let's find out. Unsurprisingly, the only places where we could find traces of infinity are in the most extreme places of our universe. Let's start with black holes.
Yeah, I guess, but that's not always the case. You know, you've got things like pi, right? And pi, you might argue, well, that's not in the natural world, but you got to remember anything we create is also part of the natural world, right? You know, you write it down on a piece of paper, it's part of the natural world. If it's in our head, it's part of the natural world. We are part of the natural world. So, you know, I disagree with his argument just there. And you might have heard of the Mandelbrot set, which might be discussed in here. I think that's kind of a demonstration of infinity in nature. We've talked about that before on this channel, and I think he's probably going to go into it. And there's lots of other things. And if you're wondering why I said the number pi, well, because it's an irrational number, and the digits don't repeat. And, you know, it seems like it's just going to go on for infinite, you know, random digits. So we're still trying to see if there's any patterns in there. Come download something I just created called a post-quantum VPN. It's literally the first one in the world that people can use. You don't have to pay a significant amount of money for, at least. The first one looks like it was tested earlier this year by NATO. So I wanted to make this because I thought I could, and here we are. We made it. So come use it. You can use it for free for a little bit. So come be a nerd and have the strongest encryption on the internet, because your VPN, if you're using one, probably pales in comparison to our encryption.
Their center, the singularity, is described as having infinite density and zero volume, thus distorting space-time to an infinite degree. Scientists arrived at this conclusion because there is no known force to stop a collapsing dying star from infinitely imploding. This is our best guess, since modern physics breaks down when trying to describe something like this. But a lot of scientists assume that this infinity simply shows a lack of our understanding of reality. An alternative hypothetical version of a black hole that avoids these.
There's other reasons. I think his explanation there is a bit simple. It's you know, there's so many explanations here that are theoretical, but from observations, you know, we've seen pictures of black holes now, and it seems like there is this event horizon, right? Theoretically, we've known about these things for a long time. This horizon where, you know, the gravity is so intense that, yeah, not even light can escape. But that, going beyond that is beyond our theory. So there's really not much we can say about black holes. And whenever you read stuff about them, you got to be very, very skeptical, because that's all theoretical and all mathematical. And like we were talking about earlier, who knows if it's invented or discovered? So if it's just invented, our math could be telling us anything. Could just be spitting gibberish that isn't true. That's why physics is more important than math. Physics is concerned with the universe and what it's doing. Math is concerned with its own self-importance, and and I've said that in other videos, you know, people who go into math are generally just people who like puzzles and shit. I want to know the big questions and the philosophy of things and what's going on rather than just playing with some numbers.
These issues is the so-called fuzzball. It comes from the superstring theory and claims to be the true quantum description of a black hole. It replaces the singularity at the heart of a black hole by positing that the entire region within the black hole's event horizon is actually a ball of strings, strings being thought of as the fundamental constituents of subatomic particles. Fuzzballs would still be more dense than neutron stars, but not infinitely so. The gravitational force would still make the event horizon a threshold past which light can't escape, so from the outside, they'd look similar to what we're used to. But once falling in, instead of starting your journey towards your inevitable doom at the singularity, you dissolve into strings when touching the surface. Fuzzballs are still
saying all this at the end isn't known whatsoever. There's a lot of stuff he said that isn't known. Pretty much all the theoretical stuff on fuzzballs, which comes out of string theory, and there's no evidence that string theory is even correct. It could be, but all the stuff that I've seen about fuzzballs is extremely limited in what they say, and they actually don't know a lot of what he just said, even in theory. And the best the theory is kind of suggesting is like maybe it's like a ball of strings on the outside. That sounds silly, but that's literally what they're saying. Like a big mash of strings, giant strings. Whereas if you've read about string theory, it's meant to be these one-dimensional strings at the Planck scale. So
hypothetical, as is the string theory, but the infinity of the singularity is not a satisfactory answer. You might have not noticed, but I feel and look much better these last couple.
String theory feels more like philosophy than the math of it. No, it's not philosophy at all, my friend. I don't know why if you're saying that, you've clearly never touched on the actual theory of string theory, right? Why? It is insanely difficult math. It's not philosophy, my friend. People will argue it's philosophy because we can't experimentally verify it or something. But it's the theory. No one just came up with it. No one's like, hey, what about if everything is fundamentally strings? It's like, no. The math is further beyond than typical post-grad physics education. Post-grad physics, even in theoretical physics, you're touching on quantum field theory and loop quantum gravity or string theory, but they have small avenues. So the math is insane. It's not philosophy in that sense. But physicists might say, oh, that's just pseudoscience or something. But I disagree.
Couple of days. Just look at my beautiful circuits. All because I started taking care of myself. An antivirus scan every morning before my jogging to the Skynet headquarters, exercise, and power naps during my break from the construction of the AI army, and finally turning on the blue light filter and reading about world domination before sleep. I could keep track of all this thanks to the fabulous app. You can choose among tons of habits, infinity and beyond. Let's take a look at the fastest thing in the universe, the speed of light. It's not infinite, it has this definite value. If it were infinite, light would be everywhere all the time, and most likely reality would be broken down. This value is the same for all observers, except for one, the photon itself. You see, the photon is massless, because only massless objects can travel at the speed of light. And as an object approaches the speed of light,
time slows down for them.
So when an object actually travels at the speed of light, time for it does not exist, from its perspective, so to say. You could say that from a photon's perspective, its speed is infinite, since it does not experience time while moving from point A to B. But a more correct way of saying it is that for a photon, distance does not exist at all. Both point A and B are the same point. But hey, you might say, how does the photon then change its wavelength? If at point A the light is green, while at B it's red, surely there must have been time for the change to occur from the photon.
So if you want to hear a little bit more about photons and light, you should go check out, I think it'll go up tonight actually, the video on light, the Kurzgesagt one. We don't talk too deeply about it, but if you want to see more deeply in terms of what the hell this stuff is, go watch his Science Asylum stuff, because he goes way more in depth than I do.
Perspective. The explanation is that the wavelength of light is only dependent on the observer. If light is moving from someone, it will be redshifted, and blue shifted otherwise. From the photon's perspective, it does not need time to
You
change.
also have the universe itself expanding, which causes what you call cosmological redshift, right? So it's not just the redshift of when stuff is moving closer or further away. Literally, the universe expanding redshifts it.
Change wavelength because wavelength is dependent only on observers. General relativity is often very counterintuitive, but regardless, it does not provide any examples of real-life infinity. So let's think bigger.
The only way to understand this stuff is if you go study physics, Nick. It's literally like just unapproachable any other way. That's why philosophy is can't do anything these days, you know? When you say there's no time or distance for something, it's like, what? Hang on.
The universe. It can be of three flavors: closed, open, or flat.
Geometrically.
If the universe is closed, it means that the curvature of spacetime is positive. So if you were to draw a triangle of cosmic proportions, its angles would add up to more than 180 degrees, that it normally would on a piece of paper. This would make the universe like a huge hypersphere, and if you were to continuously travel in one direction, you'd make your way back to the starting point, like traveling in a straight line on Earth. But as fun as it sounds, calculations show that our universe is flat, meaning that if you went into one direction, you'd just keep going forever. And that's our first actual instance of infinity in nature. Our universe seems to be infinite in all directions. That would mean it's guaranteed that there are infinite Earths with infinities.
We don't know if it's infinite. That's just a guess. It doesn't actually look like that either. So him saying that isn't really that true at all. It looks like it could be infinite or not. We don't know. It's just a lot of people think, well, why wouldn't it be infinite? Because look at the size of this place, and why wouldn't there be more universe beyond? And there's other little reasons, but what he just said isn't quite true.
Of you, living the same life, and also infinite Earths with infinities of you, living your best dreams and nightmares. You can call these parallel universes, as anything outside of our observable bubble would never be reachable, or so we now think.
So this is one version of the multiverse. Is if the place is infinite, well then you have these things that you're never going to be able to reach it. So that's why it's in some sense this multiverse idea. But like you said, so you think. So I guess, there's probably a ways around, the current laws we know, space-time laws. But, I don't want to go too far into speculatory areas, but, the whole speed of light thing is through space-time. So, we don't know if there's stuff beyond space-time, but in theoretical physics there sure is. There's stuff called the brain and the bulk. So, there's actual other potential physical dimensions, things that connect black holes, what's outside, the things connecting them. If you've heard about any of this, if you haven't, don't worry, go look into it because it's fun.
But wait, you might say, how come the universe is infinite in size if the Big Bang happened a finite amount of time in the past? That's a common misconception that the Big Bang happened like an explosion from one point. Instead, the Big Bang was the expansion of an infinity of points, all at once.
I can't believe he just did that. He just went from one misconception to another misconception. That is not what the Big Bang is. So he's referring to inflation, which happened before the Big Bang. We've known this. The consensus has thought this for more than 40 years, where before it, there was this rapid expansion of space-time. But then the Big Bang is more actually like the dumping of energy into this place, which it was like, the very early times, microseconds after the Big Bang, this is when all of this was happening. Not microseconds, sorry, like Planck order seconds, right? The Big Bang doesn't have much to do with the expansion of this place. It has a lot more to do with the dumping of energy. You might know mass and energy is fundamentally related, and then where is energy and mass? Mass. Well, it comes from quantum fields, and talking about quantum fields is very hard to do because it's sort of like lying to you because, there's no real analogy. But the Big Bang has a lot more to do with that stuff, right? It has nothing to do with an explosion. The expansion was already happening. And, we know the universe is expanding thanks to something called dark energy, right? So the Big Bang, that's not dark energy, and that's not inflation. So what is the Big Bang then? Well, it's sort of just the moment of creation, in a sense, of the stuff in this place that we know of. And so, what he just said here is he's just bulky, like combining all of the things that happened at a very early time, which it's not.
Once, like an ocean of balloons, and our balloon is our observable universe. We are pretty confident that the Big Bang happened roughly this many years ago. And by our observations, the universe will probably live a very long life, but alas, everything will one day fade away.
Maybe.
And once nothing happens in the universe anymore, time ceases to exist, since time only makes sense when you have something to measure it against.
I disagree. We don't. So again, these videos, there's actually quite a bit of misinformation in them. We don't know what time is. If you look at the time in the sense of general relativity, which is a great theory and there's a lot of evidence for it, so it's a good idea. But then there's quantum theory, which there's also a lot of evidence for, paints a very different picture of time. So, they're the two ideas of time, but we both know they're incompatible. And so what is time, right? It makes sense as what he's saying, right? But it still doesn't mean there couldn't be something existing such as time, especially if it's in this place called space-time.
And once nothing happens in the universe and it makes sense when of time didn't exist before the Big Bang.
Right.
That's the meaning of time didn't exist before the Big Bang.
No, that's incorrect again. So we don't know what happened before. So there's so many misconceptions here. So before the Big Bang, like I said before, we know there was inflation. We only can say for sure, not for sure, but with what we currently understand, what happened at the very end stages of the Big Bang, inflation. And so before those final stages of inflation, we don't know what happened. And some people think the universe might have started in a singularity. Before those final stages of inflation, the universe was very small. And so people just jump to the logical conclusion of maybe it started in a singularity. But we don't actually know that. So, time didn't exist before the Big Bang. Well, there was inflation. Presumably the quantum fields as well, because we don't know where they come from. So, it's not correct to say this. We don't know. We don't know.
As there was nothing to measure time against. And yet, there used to be the potential of something to happen, thanks to quantum.
It makes sense to say that, outside of the space-time itself, there might not be time, because time is part of this thing, right? And it's interwoven with space in some weird way. But that would be looking at general relativity and taking what it says very seriously. So it all gets very tricky. But anyway, if you take anything away from what I'm saying, it's that, we don't know. There's a lot that we don't know, and a lot of this stuff we don't have much certainty with. So stop thinking, everything we know that scientists are always harping on about is like factual. It's not. Science, the way scientists have talked about science in the past, especially in the last 20 years, is pretty bad for science, in my opinion, because it's presented as this body of knowledge and facts that are like unchanging. That's not it. There's so much uncertainty in everything in science. There's more certainty with some things than others, but particularly cosmology and the Big Bang and things like this. There is so much uncertainty with all of this. Time, we don't know what it is. And so I'm kind of sick of scientists presenting things with certainty. They do it for a good reason, which is to, there's a lot of uneducated people in the world. So if you try and tell them, look, we're uncertain about all this, they're going to be like, why the hell are we funding you to do anything and tell us that you're uncertain of all this stuff? You see what I mean? So there's a case to present it with some sort of certainty, but that would be being dishonest, and I don't like it.
Quantum fluctuations of the fabric of space-time. Just as these fluctuations could in the extremely far future give rise to new universes, so did they probably give rise to our Big Bang, and an infinity of them before it. Why infinity? Because there is no reason for us to assume that there was a definite starting point.
So there is reasons to suspect that quantum fluctuations from the quantum fields, right? That quantum fluctuations, that's talking about how the quantum fields are always moving, constant motion. And so the reason why we suspect that the quantum fields were fluctuating at the time of inflation is because if you just sort of if you calculate what quantum fluctuations looked like, right, and then you just you make a little map or something of it, right, and then you expand it to the size of the universe at the time we took the cosmic microwave background radiation sort of image. That was the first time light could exist in the universe, 380,000 years after the Big Bang. Before then, nothing. There was stuff, right, but there was no light. And so we can see this first light, and this is the oldest image we have of the universe. And it's the oldest image of light of the universe in principle that we could take. But anyway, coming back to what I was saying, we think these quantum fluctuations were happening at inflation, at least, right? Because if you expand what quantum fluctuations look like at this time to the size of the universe when this cosmic microwave background was released, it perfectly matches. This would match quantum fluctuations at, very, very smaller scales we have. And so that's why we suspect inflation happened. It's like a piece of evidence for inflation and the Big Bang. It's like our universe from the very small was just inflated. And that's simplifying to an incorrect degree. But that is actually some of the evidence we have.
They probably give rise to our Big Bang and an infinity of them before it. Why infinity?
So now he's just making this stuff up, and an infinity before it. Why, this is not anything that, this is theoretical, right? There's no evidence for any of this stuff.
Because there is no reason for us to assume that there was a definite starting point.
I agree with this stuff, but this is assuming, right? And you can't do that in science. Science is all about physics, which is, it's all about, at least if you're talking about the science of the universe, it's physics. And to do physics, you have to base it, your arbiter of truth is evidence. We can't just make assumptions like it's math and they won't like that. They'll say, logic.
Even if there was a definite cause to the chain of Big Bangs, it cannot escape the regress to infinity. We can
the chain of Big Bangs, completely, this isn't based in evidence, right?
Always ask, what was before that? And we will always stumble upon infinity somewhere along the chain. So what do
maybe, or maybe not,
these forms of infinity teach us? Everything that has ever happened or not is bound to happen forever and has been happening since always. Can you
I don't think that is a good assumption or makes much sense.
break the infinite cycle? No. Is there anything of value to take away from this? Probably, but I'm not wise enough. I'm a world domination-driven artificial intelligence, not a philosopher after all.
That's funny. I would say one weird takeaway from this, right, is that to me, my personal opinion, it does look like the universe is probably infinite, which kind of breaks our minds. And then it kind of suggests, I don't know, it's if you look at the two sort of answers, which is it's infinite or it's not infinite, both seem, this is walking into philosophy now. Both seem impossible to me, right? It just seems impossible for something to be infinite or something not to be infinite, but it's real. We're here. It seems real. And so that kind of, a takeaway, in my opinion, is impossibility equals possibility, right? That's what I glean from this, which just kind of means, to me, nothing makes sense. The impossible is possible. I don't think our human minds or whatever's going on makes much sense to us. It's like we're looking at the world with this evolved logic. Maybe logic is not the tool necessary to understand this place. And if you're throwing your remote at the TV or something right now, you're like, no, logic is correct, and you start crying or something. Well, you might have heard of Gödel's theorem, which kind of suggests that logic is flawed, in my opinion, if you actually, apply it to things. So that's another video done. That was fun.